aromatic amines will undergo something called the Sandmeyer reaction. In the Sandmeyer reaction, we take an aniline and we change it to a diazonium salt. This is the diazonium salt. Notice if the electrons leave here and jump onto this nitrogen, you've made nitrogen gas right here, an excellent leaving group. So if I treat the diazonium salt with a nucleophile, what happens? You get displacement and the nucleophile is in place of where the nitrogen was. The nucleophile can be a hydride from hypophosphorus acid. It can be hydroxide that's provided from the oxygen in copper 1 oxide, chloride or bromide from copper 1 halide. Sodium iodide gives us an iodide, and copper 1 cyanide gives us the nitrile. The biggest trouble here is remembering what provides the nucleophile. Getting the nucleophile right is what's most important. Getting the rest of the reagent is secondary. To form the diazonium salt, what do is we take aniline, any aniline, it can be substituted, and treat it with nitrous acid. Notice there's only 2 oxygens, so it's nitrous acid. That forms the diazonium salt, which is then reacted in situ. You must have a primary aniline. It cannot have other substitutions on this nitrogen. The ring can be substituted, but not the nitrogen. We treat with nitrous acid and sulfuric acid, and then we get the diazonium salt. Treatment with our various nucleophiles, what we do is hydrogen substituting, chloride substituting, hydroxide substituting, iodide substituting, or a nitrile substituting from these things that provide a nucleophile. Here are some examples. Take paramethyl-aniline and treat it with nitrous acid, and what do we get? The diazonium salt. The brackets are put around it because it's generated in situ. This is readily available. It's formed only briefly, and the nucleophile comes in and displaces this rapidly. And then what do we get? A bromotoluene. Aniline forms a diazonium salt. Sodium iodide changes it to iodobenzene. Here's another example, and what this does is it highlights the difference between the reagent for making the diazonium salt and the reagent for nitration. They look very similar. Nitric acid and sulfuric acid gives us nitration, whereas nitrous acid, only 2 oxygens, gives us formation of the diazonium salt. Treatment with copper 1 cyanide displaces the diazonium salt with the nitrile. Here we have orthomethyl-aniline forming the diazonium salt and copper cyanide giving us the nitrile. Hydrolysis can give us a benzoic acid, so remember all your other reactions. I can take paramethyl-aniline and treat it with nitrous acid to give us the diazonium salt, and then the copper 1 oxide gives us the phenol. Remember that amines are highly activating, and just treating with bromine gives us substitution with bromine in all of the activated locations. This one can't go because it's already substituted. Treatment with the diazonium salt, with nitrous acid gives the diazonium salt, and then hypophosphorus acid displaces that with a hydrogen. If I were just to take toluene and treat it with bromine, I get substitution in different places because the nitrogen is here. It activates those 2 positions, and so we get a different arrangement. Go ahead and figure out what is the outcome of each of these reactions. Treating with nitric acid and sulfuric acid gives us nitration, and because this is an ortho-para position, we can get para or ortho substitution. Here I'm showing para substitution. Hydrogenation will reduce that down to the amine. Nitrous acid and sulfuric acid then changes it to the diazonium salt, and the sodium iodide does displacement. What reagent is needed here is shown. Well, you don't get the chance to figure this one out. The diazonium salt with copper 1 oxide gives us the hydroxide.